Hi, ladies and gentlemen. Welcome to day 2 of linear systems, or systems of linear equations. Ladies and gentlemen, we've got 8 practice problems that are word problems. Yay, word problems. All right, so again, nothing new today. We've just got to package it all together, and we've got to put it all together in different forms. So we're going to write equations, we're going to make a table, and then down here we're going to do some graphing. Left you some space to do some work. We've got to figure out some domain and range. Wow, I haven't seen domain and range in years. And then, again, some space to make sure that you know how to do it in a calculator. Your teacher can check off that you have done the calculator portion correctly. So let's get right to it. In order for us to solve linear equations, we need to have equations. Last season, 2 running backs on the Steelers football team rushed for sorry about that, misprint, for a combined total of 150 yards. One rushed for 4 times as many yards as the other. How many yards were rushed by each player? All right, so let's define variables here, x and y. We've got 2 football players, 2 running backs. Let's call them R and B. Sorry, not imaginative. Running back 1 will be R. Running back B will be B. So, ladies and gentlemen, just a tip as we're writing equations. So now we've got the variables defined, or running back 1. Let's do it. Sorry, we're not looking for variables there. We're looking for like what the thing is. So we're going to go, so running back 1 is X, and running back 2 is Y. Now we can write equations with X and Y. We know what's what. Now, just a quick tip, ladies and gentlemen. It's one equation per sentence. Okay? 1 equation per sentence. There's 1 sentence, 2 sentences, 3 sentences. Except for this one is a question. That doesn't count. So we've got one sentence right here. And then the first sentence. Guess what? The first sentence has the first equation. The second sentence has the second equation. So we've got 2 football players combined total. Total is your key word for stuff that is added together. And if you've got stuff that is added together, it's got to equal something. What are the 2 things that are added together? The rush yards for running back 1 and the rush yards for running back 2 added together equals 1,500. That's your first equation. The second equation, 1, running back 1, and we usually rushed for 4 times as many yards as Y. So running back 1 rushed for 4 times as many yards as running back 2, as the other one. So there's our second equation. So now we got 2 equations. Now, what form is this equation? That's right, it's standard form. Do we like standard form? Nope, not as much as we like slope-intercept form. What form is this in? Slope-intercept form. Fantastic. So ladies and gentlemen, this space down here for y1 and y2 is for the equations that you would put in your calculator. The equations that we put in our calculator are always in slope-intercept form. So this one's good. This one has to be changed. We need to solve for y. And this one's pretty simple. We're simply going to make 0 right here. Get this on the other side. And we've got y equals negative x plus 1,500. All right. So now, independent and dependent variables. So this is x and this is y. And we need to make a table. Now, easiest way to make a table is going to be to use our calculator to do it. And we're going to do that in just a second. We need to draw a graph. But that 1,500 there, that means that we're going to have to change our scale. So if we make this 1 and this 2 and this 3 and this 4 and this 5, if we go by ones, 1,500 is going to be way off the map. So we're going to need to change our scale to something that makes sense. Let's do that in just a moment. Now, right here, ladies and gentlemen, substitute for y. Now this might be the best place to start because we need to figure out what's going on here. So let's actually do the substitution, and that comes out to, remember the y's are equal to each other, just like in our last class. So we're going to have, let's see if I can see it down here, negative y plus 1500 equals 4x. So now everything's written in terms of x. Now let's see if we can graph that. Where's my handy dandy calculator? And let's see what we got. Clear this out, clear, clear. Come back up here, negative x plus 1500. And then we're going to come down here to 4x. And then we're going to graph it. See what happens, see what happens, see what happens. There's one. And where's the other one? I don't see it. Uh-oh. Remember, this is a y-intercept of 1500. So the y-intercept of 1500 is going to be crazy big. So we need to come down here and we want to change all of our window settings right here. So let's see, y max, we need something really big, really big. So if we make it 1500, which is really big, it won't be on the screen. It'll be right on top of the edge of the screen. So let's make this negative 2000. I know it's big numbers. 2000. Leave the scale at 1, negative 2000, and 2000. And let's graph this again and see what happens. There's my first line. Oh, there it is. There it is. Awesome. Awesome. Awesome sauce. Second calc 0, second calc, no, not second calc 0, second calc intersect. And then first curve, yes. Second curve, yes. Guess, no. So the intersection is at 300. So we know graphically the intersection, we know the answer is going to be 300, comma, 1200. All right, so that's good. That's good, close parentheses there. Let's look at the graph. Let's do the graph first. Now, ladies and gentlemen, we are not sketching. This is not art class. We're not simply going to draw a line in here and draw a line in here to make it look like what we've got. What we're actually going to do is we need to move to the table because we need to plot points and then we connect points, okay? We need to plot points and then we connect points. So let's go to the table. Let's figure out the best way to do this. Now, this is going by ones. Does this make sense to go by ones here? Is that going to help us out? If we have a scale, if we're going 2,000, 500, 1,000, 1,500, 2,000, if we go by 500s for each one of these, then that makes a little bit more sense. So let's go back to, let's go to second table set, and let's change our table. We're going to go by 500s because, look, 1, 2, 3, 4, we've got 5 lines, but we need to get to like 2,000. So in order to make that happen, we're going to go by 500s. And that's changing, we're changing our scale so that our graph and our data fits into our graph right here. So we can go back to graph, it should look the same. If we pull up the table now, second table, now that looks a bit, oh, second table set, didn't want to start at 3, want to start at 0. Second table, now, oh, now we got some nice numbers. Look at those nice numbers, nice round numbers here. So what we want to do is we want to plot some point. We want to get some points in here, and we want to plot some points on the graph and connect some dots. So what we're looking for, ladies and gentlemen, if you notice, there's the x values, and then there are the 2 y values. We're looking for when these values are the same. Where are these values the same? You're saying, Valdez, it's not the same. Well, why isn't it the same? Oh, let's look at this for a second. We can't go by 3. We can go by 500 for the scale of the graph, but that doesn't help us find the data points for the table. If we look at our answer here, we know the answer, we should go by 100s. We should go by 100. So let's go back to second table set, and let's go by 100. Come back here, and we're going to, we start at 0. So second table. Okay, now, look, this is the x value, and these are the 2 y values. These are 2 different lines. So this is line 1, running back 1, running back 2. Where are they the same? They're the same right here. So the x value, 300, 1200, 300, 300, 1200. Here's the answer. So the solution is when this is 300 and when this is 1200. And what I want you to do right here is I just want you to use a couple of points, pick 2 points above the solution, so 100 and 200. So for 100, oh, you know what? I messed up this graph, or this table. What we actually need to do is we need to call this y1, and we need to put a y2 right here. I apologize. So add a third column, so that makes it look the same. And then, so we've got 100 for y1, we've got a y coordinate of 1400 and a y coordinate of 400. And let's come down to, so we've got 200 right here, and then we're going to put it in the 300, and we're going to put in 800. And then, so that's all the same. It should be 1200. We're going to come down here, so 400, and then 1100, and 1600, 500, 1000, and 2000. Now we've got points that can be plotted on our graph. Remember, we're still going to go by 500 here. Each one of these lines is going to be 500. Now we just need to plot the points. So we know that our answer is going to be at 300, 1200. So you can guesstimate a little bit. You can estimate 300 is going to be about here. This is 500. 300 is here. 5, 10, 1200 is going to be right in here somewhere. Okay? So that's the first point. And then let's do this line right here. So 100, 1400, 100, 1400, 200, 1200. Okay, so we know that that line is going to look something like that. And then let's come to these x coordinates and these y coordinates. So we've still got that one. So 100, 400. It's going to look like this. And let's do just this one for fun. 5, 2000. 500, 5, 10, 15, 2000. Now, if we did that right, that should connect a little bit. And it looks like it's a little off. Okay. So use your table, setting, second table set, to figure out how to look at the table in order to find your solution. This one came out nice and neat, and they should all come out relatively nice and neat by using 100 as change value, going by 100s. On your scale, you'd have to figure out what your scale is in order for your data to fit, and this scale had to be 500. And now we can come down and do some algebra. So let's solve for x. Let's get x by itself. And so we need to make that into 0 plus x. So we've got 1500 equals 5x divided by 5 divided by 5. X equals 300, which is exactly what it's supposed to equal. So 300. Brilliant, awesome. And now we can take this value and substitute it into any one of our equations. Let's go back to this one right here, because that's going to be nice and easy. So we've got y equals 4 times 300. 4 times 300, y equals 1200, just like it's supposed to. So now we did the solve and substitute. And so we've got the answer algebraically, we found the answer graphically, and we looking at the answer as a table as well. And now, reasonable domain and range, reasonable domain and range, reasonable domain and range. What are the possible values for x and y? What are the possible values for x and y? What are the possible values for x and y? In order for them to be combined, there needs to be a total of 1,500 yards. So for the domain, that's x and that's y, What is the smallest value that makes sense? So x is running back 1. How many? You know what? On a couple of these problems, a reasonable domain and range isn't going to make sense because some of them are in standard form. So what we're going to do is we're going to nix on all of your practice problems, don't do the domain and range, because I didn't think that through far enough, because it doesn't make sense, because the units are running backs. What's the lowest value of running backs? 1. What's the greatest number of running backs? 1. So that doesn't make sense. So you caught a break, ladies and gentlemen. You don't have to do the domain and range, but you do have to write the equations. You have to get them in slope-intercept form. You have to use your calculator. You have to use your calculator to show the answer. You have to put the answer, use your table, figure out how to use your table in the table set in order to show your solution, which is this one right here. You need to figure out your scale, and you need to graph your answers. And then you need to substitute and solve in order to find the answer mathematically.